Our first speaker this evening is Greg Poore from Bioengineering.
Thank you for the introduction. I recognize that these are difficult times for many. So before beginning my talk, I want to invite everyone to do something with me. For the next few seconds, I want you to think of the people who have helped you become who you are. For me, my grandmother, shown here, was one of these people. She spent months with my sister and I every year for nearly 20 years, from my birth to the start of college. And then something tragic happened. Halfway through my first year of college, my grandmother was suddenly diagnosed with stage 4 pancreatic cancer. She had no symptoms. She had no warning. She tried therapy, but it failed just a few weeks later. And just as sudden as it came, just 33 days after her initial diagnosis, I found myself mourning her death. This tremendously painful and sudden loss of my grandmother catapulted me into cancer research and medicine. It is the reason why I am a medical student at UCSD. But the more that I searched, even in medicine, the fewer answers that I found. Even with the best therapies, the survival rate of pancreatic cancer was just 5%. And it really wasn't until my second year of medical school that I began to see hope on the horizon. By complete accident, researchers in Israel discovered that microbes, non-human things, were inhabiting over 75% of pancreatic cancers. And they were actually likely responsible for their deadliness. This slide shows several examples. Cancer cells are fluorescently stained in blue and microbes are in red. Perhaps most astonishing, though, is that these microbes are actually eating away the chemotherapy that patients received, making them resistant to treatment. And the kinds of diagnostic procedures physicians were doing to see if they had cancer were introducing these microbes into their cancers. Like a sniper looking tirelessly for his target, I finally found a new perspective for my questions about cancer in these crosshairs. Cancer itself was not sterile. Now, we have over 100 trillion microbes that live on us and in us. For comparison, that's 1,000 times more than there are stars in the Milky Way, or 3 times the number of human cells on your body. In essence, you are a modern-day centaur with you and your microbes. And yet, for decades, virtually every single cancer has been treated as a sterile disease. Joining hands with researcher Rob Knight at UCSD, I made it my goal to explore microbial DNA in over 30 cancer types and across 10,000 patients to see if microbes could be found in most major cancer types in the human body. The results, which were published last month in Nature, suggest an entirely new class of cancer diagnostics, where we can actually diagnose human cancers using microbial features in both tumors and blood. Moreover, these microbial-based cancer diagnostics can often be more sensitive and specific than existing human-based cancer diagnostics, meaning that we could potentially find and treat cancer earlier. Additionally, to reach people in the clinic like my grandmother, we have started a company to bring this technology to them. Together, we are building a new era of microbial-based cancer diagnostics, and I hope that it will save people from the pain that my grandmother and family had to go through. And until it does, there's good work to do.